Hello, welcome to my probability and statistics concept video presentation. My name is V.V. Raghuram. I'm from CSE IML C section and my roll number is H4. Today, this presentation is about samplings and types of samplings used in probability and statistics of engineering class. So, this is a presentation on sampling distribution types, a brief explanation. Sampling distribution, there are three distinct types of distribution of data, which are population distribution characterizes the distribution of elements of a population. Sample distribution characterizes the distribution of elements of a sample drawn from a population. Sampling distribution describes the expected behavior of a large number of simple random samples drawn from the same population. Sampling distribution continues the theoretical basis of statistical interference and are of considerate importance in business decision making. Sampling distributions are important in statistics because they provide a simplifications on the route to statistical interference. Definition: a sampling distribution is a theoretical probability distribution of a statistics obtained through a large number of samples drawn from a specific population. The sampling distribution is a graph of statistics. That means it may be mean, absolute value of deviation from the mean, range, standard deviation of the sample, unbiased estimation of variance, and variance of the sample for sample data. Sampling distribution is a theoretical distribution of an infinite number of samples, means of equal size taken from a population. So the characteristics are usually an univariate distribution, closely approximate a normal distribution. Simple statistic is a random variable. Sample mean, sample and proportion, a theoretical probability distribution. The form of a sampling distribution refers to the shape of the particular curve that describes the distribution. Functions of sampling distribution. Sampling distribution is a graph which performs several duties to share and show data graphically. Sampling distribution works for mean absolute value of the deviation from the mean, range, standard deviation of the sample, unbiased estimation of the sample, variance of the sample. Why sampling distribution is important? It is important because it shows the properties of statistics, selection of distribution type to model score, and then we use hypothesis test on sampling distribution. Statistics have different properties as estimators of a population parameters. The sampling distribution of a statistic provides a window into some of the important properties. For example, if the expected value of a statistic is equal to the expected value of the corresponding population parameter, the statistic is said to be unbiased. Consistency is another valuable property to have in estimation of population parameter, as the statistic with the smallest standard error is preferred as an estimator. A statistic used to estimate a model parameter for the corresponding population parameter, everything else being equal. Consistency is another valuable property to have in estimation of population parameter, as the statistic with the smallest standard error is preferred as an estimator. A statistic used to estimate a model parameter of the corresponding population parameter, everything else being equal. Selection of distribution type 2 model scores. The sampling distribution provides the theoretical foundation to select a distribution for many useful measures. For example, the central limit theorem describes why a measure such as intelligence that may be considered a summation of a number of independent quantities would be necessarily be distributed as normal curve or Gaussian curve. Hypothesis testing. The sample distribution is integral to hypothesis testing procedure. The sampling distribution is used in hypothesis testing to create a model of what the world would look like to give the null hypothesis was true and statistic was collected an infinite number of times. A single sample is taken, the sample is calculated, and then it is compared to model created by the sampling distribution of that statistic. When the null hypothesis 2, the sampling statistic is unlikely given the model, then the model is rejected, and a rejected model effect is more likely. Types of sampling distribution. The types of sampling distribution are as follows. The sampling distribution of the mean. Sampling distribution of means of a population data is defined as the theoretical probability distribution of the sample means which are obtained by extracting all the possible samples having the same size for the given population. Given an finite population with the mean m and variance s2 s square, when the sample from a normally distributed population, it can be shown that the distribution of sample mean will have the following properties. The distribution of x bar will be normal. The new x bar of the distribution of the values of x bar will be the same as the mean of population from which the samples were drawn. Then nu x bar is equal to nu. The variance sigma x square of distribution of x bar will be equal to variance of the population divided by sample size, hinting that x square sigma x bar is equal to sigma square by n. Central limit theorem. The central limit theorem, first introduced by de Moivre during the early 18th century, happens to be the most important theorem in statistics. According to this theorem, if we select a large number of simple random samples, for example from any population distribution, and determine the mean of each sample, the distribution of these sample means will tend to be described by the normal probability distribution with a mean nu and variance sigma square by n. Or in other words, we can say that the sampling distribution of the sample means approaches to a normal distribution. Symbolically, the theorem can be explained as following. So left side we can see the graph which represents the central limit theorem. If the population itself is normal distribution, it is distributed using nu. The sampling distribution of the sample mean is normally distributed for any sample size n with x bar when given n independent random variables x1, x2, x3, x until xn, we have the same distribution no matter what the distribution. Then x is equals to x1 plus x2 plus x3 so on until xn is a normal variate. The mean nu and variance sigma square of x are nu is equals to nu1 until nu1 plus nu2 plus nu3 plus until nu n is equals to n nu1. Sigma square is equals to sigma square 1 plus sigma square 2 plus sigma square 3 plus sigma square n, which is equals to n sigma square 1. Sampling distribution of the proportion. Sampling distribution of the proportion is found when the sampling proportion and proportion of successes are given. Sampling proportion tends to target the value of proportion. Under certain conditions, the distribution of sample proportion can be approximated by a normal distribution. Example of proportion. Example of sampling distribution of proportion is the girls from a separate space for two randomly selected birds, BB, BG, GB, and GG. All four outcomes are equally likely. P of 0 girls is equals to 0.25, P of 1 girl is equals to 0.50, P of 2 girls is equals to 0.75. Standard error of the sampling distribution. The sampling distribution has a standard deviation. The mean of the sampling distribution will be the same as the population mean, but the standard deviation will be smaller than the population standard deviation. The standard deviation of the sampling distribution has special name, the standard error or something, the standard error of the mean. The variation of sample mean around the population mean is the sampling error and is measured using statistic known as standard error of the mean. This is an estimation of the amount that a sample mean is likely to differ from the population mean. This consideration is important because sampling theory tells us that 68% of all the samples means will lie between plus or minus one standard error from the population mean, and 95% of the all sample mean will lie between plus or minus 1.6 standard errors from the population. Purpose allow us to quantify the extent to which a test provides accurate scores. If the standard error is smaller, the range of population mean will be narrower. When the standard error is larger, the range of population mean will be wider. Application 95% CI is equals to mean plus or minus 1.9 of SEM. 99% of CI is equals to mean plus or minus 2.58 into SEM. These are the standard error table formulas for sampling distribution of means, proportion, standard deviation, semi-integrated ranges, variances, coefficient of variance. Thank you. Thank you. This is the end of my presentation about sampling distribution and its types.